Okay, we reviewed the first, well, I guess it'd be 1, 2, 3, 4, 6 problems, but they're numbered. Let me see. Let me bring it up. Sure. This is on As You Learn. It's an outline. There's 10 problems on the exam. 3 of them come from here, which we covered yesterday. 2 from this one, and then 1 of each of the rest. 7, 8, 9, 10, yeah. But we did numbers 1 through 3. Number 4. Page 223, figure 23. See if I can make it a little bit bigger. Oh, okay. First part says each red arrow is labeled with a plus or minus sign. Describe in your own words the meaning of these labels. So for the birth to population red label, so for the birth to population one, that would be this one here. What this was births. The stock is your population, and then leaving the stock would be the deaths. What this one means is as the population grows, the births grow. For the first part, it's always a growth. So wherever the arrow is starting, and it's starting here and then going here, whatever it's starting is always a growth. If it's a plus, then this is also a growth. If it were a minus, then this would be a decrease. The other one is population to death. So the red curve that goes from population to death means a growth or increase in population. Then there's, and it's positive, so increase in death. That's what the red arrow would tell you. So those are both pluses. That's why this one isn't a birth or an increase. Either word is fine. But the minus, then the only thing that would change is this would be a decrease or this one. Any questions on the arrow? Let's See what this one is. I think it's a +2. Yeah, it's a +2. Any questions? Part B, the strength of each feedback loop and if amplifying or stabilizing. So if we do the birth to population feedback loop first, it's this loop. You multiply your signs, a positive and a positive is a positive. So the strength is the 1.22%. The positive means it's amplifying. Relation to death. Multiplying those, we have a negative times a positive. So strength 0.75. When it's negative, it's stabilizing. So the negative is stabilizing, the positive is amplifying. You multiply the two together. Any questions on that part? Part C is find the overall strength of the feedback loop and is it amplifying or stabilizing? So overall strength. You add the strength of your feedback loops together. So we have a positive 1.22 plus a negative, or that would just mean minus 0.75. So the overall strength is 0.47. And the positive, that means it's amplifying. So there's one problem like that. Any questions on it? Number 5, 252. 1 and 2. So there's one like this. Notice that the variable is in the exponent. I probably could do it on this page. Number 1, 5 to the x equals 16,000. Express your answer to 2 decimal places. Now we're trying to find x, and it's in the variable. Remember, last class we talked about the log x to the r, that we could bring that exponent in front. So if we take the log of both sides, then we can bring the variable down. Now we can bring that exponent. We're trying to get x by itself. This is being multiplied. Always do the opposite. Opposite of multiplication, division. And then plug this into your calculator, and it says to round 2 decimal places. Okay, well, there we go. Rounding 2 decimal places, because of the 4, the 1 will stay a 1. It needs to be a 5 or higher. So 6.01. Any questions? You could always check your answer. It was 5 to the x. So you can do 5 to the 6.01, which is close to 16,000. The rounding is what made the difference. We rounded. Any questions?
Why did you put 1 5 in parentheses, or two of the 5s in parentheses, and leave the 1 under the log 16,000?
You can rate it either way. Your book's been putting parentheses around all of them. I never do, so I was trying to do it. But when you hit the log button, it should already put one of the parentheses. Whoops, I missed one. And you have to put the other one. But log of 5 and the log with parentheses will be the exact same answer.
Thank you.
You're welcome. It could have been put here too. And here. Where you need to be careful is when there's more than one term, but when it's just one term, you don't have to have the parentheses. Okay, let's try the other one. Try number 2. Are we getting 4.40? We take the log of both sides. Then the exponent can come down in front. This is being multiplied, so divide by it to get rid of it. We're getting 4.40. If it is saying 2 decimal places, even when it's a 0, you need to show that. So I know you went 2 decimal places, not just 1 decimal place. Any questions on that one? Okay, page 252, number 3. Why the pages keep going. 252. Oh, we're on it, number 3. In 1990, 7.6 million children worldwide died before reaching the age of 5. In 2015, the corresponding figure was 3.7 million. Express this change in absolute terms, in relative terms, and in logarithmic terms. Which way of expressing the change do you think is most effective and useful? Okay, absolute change, I have the formulas, are on the paper. So absolute change is new minus old, or new minus original, or new minus reference. You'll see all 3, but it's the new value minus the old value. Relative change, you take the new minus the old and divide by the old. And then it said percent, so multiply by 100 to make a percent. Logarithmic terms is this formula, 2.3 log and new divided by old. And that would be in Napers. And they wanted it in centinapers. So centi multiplied by 100. So those are the 3 formulas. Remember, you can have a formula list, or you could have this outline set up so then they're together. Okay, so if we find absolute change, and it was new would be the 3.7 million. So 3.7 minus 6.6. What did I do? Getting a negative 3.9 million. From 1990 to 2015, there was a decrease because it's negative of 3.9 million decrease in deaths. Something like that. But from 1990 to 2015, there was a decrease in the death of children under 5 by 3.9 million, or 3.9 million children. I don't know. I think that's probably the best way. But you want decrease because it's negative, and it's 3.9 million children. So there was a decrease by 3.9 million children deaths. But absolute change keeps the same units. So it's million children's deaths under the age of 5. So this kept the same units. The other two do not. So B, relative percent change, new minus old divided by old, and then we're going to multiply by 100 to make it a percent. Now we've already subtracted it up here. So it's a negative 3.9 million divided by the original or the old value, which was the 7.6. Million children can cancel. Just divide and then multiply by 100. So you should be getting a negative 51%. So the amount of children's deaths from 1990 to 2015 decreased by 51%. And you have to be able to write it in a sentence so I know what it means. But it was a decrease 51%. The last one.
I have a quick question.
Uh-huh.
So when it comes to like writing out our answers in like a sentence form, is that just for like the problems like this, or are we supposed to like write out sentence answers for like number 5 when we did like the log answers?
No, you would not need to.
Okay, cool.
You
I
know,
just wanted-
I'll make a note. What I'll do is on the test, I'll tell you, like, if it says explain, you definitely need sentences. This one, somewhere it says which one would you use? But these, I'll put write and complete sentences on the ones that have to be.
okay, just wanted to check. Thank you.
Nope, that's fine. Yeah, like the ones where you're rewriting, or some of these where you just had to say, what's the cluster? You can just put the number. Any questions on that one? The last one, the logarithm one, is (2.3 log), and then it's new over old. And if you want to make it go right into the sending neighbors, since that's what they wanted, you can multiply by 100. New was 3.7 million children's deaths, and the old was 7.6. Units all cancel here. Now, these are usually used with metric. This one, instead of percents, they use this. I just rounded to the whole unit. So a negative 72 centimeters. From 1990 to 2015, there was a decrease in the deaths of children under 5 by 72 centimeters. So this would just be in place of, it could be in place of this, it can be in place of your percent.
What is centimeters? Like, what is that?
It's a unit
it's a
that goes
unit.
with logarithms.
Oh, okay.
Yeah. It's just a measurement, kind of like a percent, but because if you think we have a meter and there's a yard, centimeter goes with percent. So it's the metric, kind of the metric of a percent.
So
Oh, okay.
I think
Well,
it's good to start learning this. I never used NAPERS before. But from what I read, it's similar to the percent, but it's the metric.
So when we did B and we did the new divided by old, we used a negative 3.9
It
over
was,
7.6.
yeah.
Why did we do 3.7 or 3.9 instead of, oh yeah, no, sorry. Why did we do 3.7 divided by 7.6 in C?
Okay, so on this one, it's new divided by old. On this one, it's new minus old. And since we had already subtracted new minus old up here, I used the negative 3.9.
Gotcha.
Mhm. For which one you would prefer, that's kind of up to you. It's also kind of up to what they would be using it for. In the United States, we probably would never use this one. It's just not a unit we use. But as long as you, I'll probably just have you write a sentence for each. I think it said which one is more relevant. And that all depends, because is it more significant to say how many less children are dying? Because if they don't know how many 5-year-olds were passing away, then saying 51%, it went down by 51%. Yeah, that sounds like a big drop, but was it very large to begin with? Here, saying it dropped by 3.9 million children tells you there was a lot of children under the age of 5 that were dying. So it kind of depends on what your article's about. If you are stating how many there were to begin with, the 7.6 million. So this tells you more of the size of it. This tells you 51% it went down by, but was there a lot to begin with? The person might not know. And so there's different ways of looking at it, and there would be no wrong answer. My main concern is that, you know, when you do absolute change, the units stay the same, million children under the age of 5. When you do relative percent change, your answer is 8%. And when you do the log, your answer is in centimeters, which is similar to a percent, but it's in metric or log form. Any questions on that?
Wait, so why do we use log again? Like how is it different from the percent? Like, because I know it's similar to a percentage, but like I'm just wondering like why we use log.
We, in this case, I think percent is better because of the country we live in, but in other countries, instead of the percent, they will use this more. It's just more common. Just like we use a yard and they use a meter. It's just the way we've grown up.
Oh, okay. I wasn't
Yeah.
sure if it was like
Yeah.
different in some way.
No, and I think the book threw this in there because when you're reading things from other countries, then on sustainability, this will probably come up. Because instead of percents, they're going to use centimeters. And then now you have an idea of what it means.
Right, okay.
Any questions? One more. Number.
Do we have to write a sentence for C?
Yeah, it would be the exact same sentence as the one above
Okay.
here, except you'd put this in. So it was a decrease. This would be 72 centimeters. So take out the 51% and put 72, and you can even use CN. For centimeters. Because the centi is the centi, like centimeters. It's just the metric. Number 7, page 2. Oh, I think this one's an easy one. 255, number 34. Number 34 is describe the meaning of the term carrying capacity in your own words. What is carrying capacity? So here, I'll give an example. The pond has a carrying capacity of 20 bullfrogs. What does carrying capacity mean?
It means like how much the pond, like how many or like how much resources it has to be able to sustain, like it has enough resources to be able to I guess sustain 20 bullfrogs.
Yes, exactly. So if it has a carrying capacity of 20 bullfrogs, that means 20 bullfrogs will use up enough of the pond, but it will keep growing back. It can sustain 20 of them. If you have more than that, then the pond is likely to not be able to recover quick enough for them to keep living. When it gets to be too many, then the pond will start dying. It won't be able to regrow, and the bullfrogs become sick or leave. So carrying capacity is how much that area can hold and stay sustainable for those animals. Now, is it better for me to write an example and you use the example, or just ask the question like they did?
Definitely use an example. I feel like.
Yeah, that that question is really broad.
Yeah, I think so too. The only thing is putting this helps you know what the meaning is, whereas just putting that, then you got to try and figure it out more. But I think it's easier to explain if you have an example. Any questions on that?
So, like, would a good way to word it be to say that there is enough renewable resources in the pond to sustain 20 bullfrogs?
Yes, I think that's a good one. Mhm. So that would be one way of saying it. The pond can have up to 20 bullfrogs and still be able to sustain them and grow. Any questions on that? Okay, any questions on anything for the income? I would use this paper then. That way you have all the formulas, and then you could always write the definitions in here, like things to help you remember what they are. You won't be asked the definition, you'll be asked, like you'll have to draw a complete network and then you'll be asked the questions. And then this is a separate question. Any questions? So you can have these practice problems with you if you want. You want to know how to do most of them, though. Don't think you can look up every single one. Like these, you should be able to do probably all three in a minute. And then this shouldn't take very long, and neither should this one. And that way you leave time for the rest. This is another easy one if you know how to do it. That's the one with the exponentially. I don't remember what it was, but that's this one. And this one shouldn't be very long either. Any questions? Positive? Okay. Has everyone got to look at the take home?
I haven't yet.
Okay. Does anyone have questions on it yet? We could wait till tomorrow and answer questions, but these will be 10 points each and come to 50 points because, I mean, you could always ask me questions. So there's no reason that you don't get these all right. So that's half the test. You've already got 50 points. The other part will only be, there'll be 5 points each.
Wait, so is the take home due on Friday too?
No, it's due Sunday night.
Oh, okay.
I was a little confused with the second one,
Mhm.
just because it was kind of making my brain hurt. But it's just like because it didn't sound like mathematic, it sounded just like more of like a mental problem. Since it was
Yeah,
like,
I think when I saw this there, I thought, I want to see what people say. I think what it's kind of using is the bystander and the, what's the other word I want? Cascading effect.
oh, okay, because I was thinking, I was like, this sounds more like a psychological question.
Yeah, it kind of, I mean, when you think about it, and if you think about things you're voting for in school and you have to say them out loud, you may not say what you would have said because there's everybody listening and hearing your opinion. And the more people that are picking one opinion, and then your opinion may have been different, but are you going to say that, or are you going to just go with everybody else because you know you're going to lose anyways, or think you are? And so that pressure that's put on you is kind of similar to the bystander. You're standing there and everyone's giving their answer and you're like, oh, well, I think they're wrong, but maybe I'm wrong. And so that's kind of what that effect is. So what's something we could do to get away from that? Anyone?
Like write everybody's votes down and submit them.
Yes, a silent ballot. So then nobody knows who's voting for what. And that goes with anything. My son plays tennis. You're going to pick the captain of the team. If one person starts out and then the next person votes for the same person, but maybe you didn't want to vote for that person, but now you feel funny saying somebody else's name. But if you do it on a written ballot, nobody knows who said what. And then you could put down how you feel.
Okay, because I wanted to check. I was like, no math here.
Yeah, there's no math in that one. It's just more of a logic problem. So it's still mathematically based, but it's logical.
Thank you.
You're welcome. So just a paragraph answering those is fine, 4 or 5 sentences, whatever you need. Yeah, I thought that was kind of different. Any other ones? Static reserve and exponential reserve, the formulas are in the book, but I could give you them. And there's that 3. So static reserve. No, let me just find the page it's on. That way, then you'll have the definition and everything. When you're using the book and did I close the book? You're not sure where something is or what section we did it in. You can go to the index. Most of the words were there. Moves a little slow sometimes. But these were the 2 I didn't remember the formula for, so I had to look them up. So if you click on index, and then you just go to, what was the first one? Exponential reserve. Exponential reserve, page 201. Has the definition so you understand what it means. Here's the formula for static reserve and exponential reserve. So they're on page 201. And I believe if you go back 1 page, it gives you the static reserve definition. So page 201. And then if we go back 1. There it is, static reserve definition. It's the length of time it will last at the present rate of consumption. So whatever our rate is of consumption, this will tell you how long it will stay there. And the exponential tells you the same thing, but it's when you have an exponential growth. So this one uses a rate, like a percentage, that's your R. This one has how much there is, and then like this is same unit. So if this is 5,000 barrels, maybe we're using 10 barrels a year. That's what Q is. So it is a rate, but it's a rate in the same units as R, where this lowercase r is a percent. So this problem, the first one, static, does not use the percent, only exponential does. And that's for number 3. But see, go ahead and try the problems for tomorrow, the 5 of them. and see where you have questions. Also look at the in-class part and see if you have any questions on those. So read through these and see if you have any questions. Look over the problems we did the last 2 days, maybe watch the video again and see if there's any questions you have when you're watching it. You could write them down. And I can go over those first. And as you're doing the take home, if you have questions, email or text me a picture. Texting's faster. My son has tennis matches almost every night this week. So if I get a text, I'll feel it vibrate and I can answer quicker than an email. Any questions?